Hi, everyone. Yes, I'm Alex Thissen. I'm from the Netherlands. Work at a company, Xspirit. We do consulting, and we consult a lot of companies that transition from their on-premises into the cloud. And I mostly work with developers and development teams, the architects. Who of you is also doing development? Okay, 4 hands. This is about development, but it also has to do a lot with how you roll out, release your applications in an environment. So let's get started. Since this is a DevOps conference, what I usually hear is in development teams and together with operations is they say, okay, we are autonomous now. We have full control over everything. So from our infrastructure up into the code that we deploy on it, now we should be able to deploy multiple times per day and release our software just as much as we like. Instead of doing that only once a month. And I've worked at enterprise companies that actually have a calendar and they release every quarter of a year. And it's very scary because if it doesn't work, they need to roll back during the weekend and the weekend is lost and the delay by another month or so. So getting from once a month to multiple times a day is like the promise that DevOps on the development side combined with the IT operations should do. We only roll forward, we never go back, that's the good stuff. Okay, that's what they tell management because they want to have the DevOps things. And then this manager comes along or this project lead and he says, okay, I've got something new, the business wants something new, and build that. It's a small feature, get it in this sprint. Do you know the movie, Office Space? Yeah, okay, good. So that would be great. And then you think like, okay, the team gathers and they're like, okay, we've heard about feature branching. Let's do that. Let's make up something because it's a new feature. We've heard about feature branching in Git flow, and we'll use that methodology, and that should get us to do, the new feature within a month. And you start doing this, and what it does this is Git flow, so it has multiple branches for hotfixes, releases, and the master branch. But it's about these feature branches, and each feature team creates its own branch and it starts working on it. But as it turns out, it's not that easy because then reality kicks in and all of a sudden the teams disappear underwater. They have their own branch, so they're in their own world and they can build for as long as they want. And they cannot finish maybe the small thing that they need to build, maybe it's a bigger thing, but they just keep on their branch even at the end of the sprint and they say, well, we can't deploy yet because it's not finished. And as soon as we do the merge back to development or to release, then, it has to be done because otherwise it will not fit. So that all of a sudden it becomes a blocker and they wait until they merge back to the development branch and it becomes harder and harder. And then there's this deadline that approaches, so they have these death marches because it becomes so complicated and the testing becomes even more difficult. And eventually you end up with something that is a bit like waterfall. Now the promise of the feature flags is, what if we stop doing the feature branches like we just saw and go to code branches? Because you see an if statement is like a branch. It goes one way or the other. And that could be the old functionality and the new functionality, or maybe just the new functionality if a feature is enabled. So these feature flags, the things that say, is it enabled or not, allow you to put in implementation, deploy it out to production, but not have it active yet. And that's kind of the general idea for feature flags. So, if you start doing that, then all of a sudden you go back to this one big branch. You can do trunk-based development that your master branch could be the truth. And there would be separate branches, but they would be short-lived. And even if it's not finished, you can still merge it back to master every day a couple of times because it's hidden behind an if statement. So the code is not exercised and it can remain there. That also means that you get this decoupling, and we'll talk about this a bit more, from deploying your code, so getting your code on the hosting system, versus releasing it by flipping the switch. Now, why is this good? Well, if you get away from the repository branches, life becomes easier. This is actually one of the simplest ways to do to integrate new functionality while maintaining the old. And there are other ways, such as, for example, if you use service meshes, you can do smart routing. You can have load balancers or the mesh itself that does smart routing. But you need to be in an environment that can offer that functionality. And this is the simplest form, and it's very direct. It's inside of your code. And with this, you can do all these new types of, well, engaging your production system. So for example, you can do testing in production because you have old and new side by side, and you can just flip the switch whenever you want to, which means that you can do flighting. You can also immediately remove the old functionality. Well, you don't actually remove it, but you make it inactive by flipping the switch back. So it's a kill switch. If something goes wrong, you say, whoa, this is not good, then just toggle it back. And there's also an option to be more selective in who gets new functionality or not. So you can inspect the profile of a user and say, these users do get it, the other users do not get it yet. And that's the general idea, is that you already have your code in production. It's constantly streaming into production, and once it's finished, you are able to release it. So decoupling deployment from release. And from a code perspective, without going into actual code, so let's assume that this is your original logic, and the program flows through the logic. And you want to have this new feature. This is what you would do without feature flags. The new feature is introduced, and it completely replaces the old. So all of a sudden, you have the new stuff in place, and there's no way to get the old back except for doing a rollback. So if it's not good, you need to revert to the old one. And this is usually something that might end up even worse, because you deploy something new, it's not working as expected, and then you try to get back to the old state again, whereas the new one wasn't working either. So sometimes it even makes matters worse. Essentially, if you do this, then it's all or nothing. It has to work, otherwise we need to go back. So this is the old way. If you do the new way, then you essentially introduce this if statement. And the original feature might be there. It might be new functionality, so completely new. That means that there is no original thing, but just assume that there is a search algorithm and you want to replace it with an even better search algorithm. What you would do is you would start building the new feature. That is what is planned. It's gray, it's not green yet. Green means it's done. Gray in this picture says, okay, we're not done yet. But we build the logic. So we build this if statement, that's the diamond shape, and you say that if the if statement is taken, you go through the new feature. But as you see, it's grayed out, so it's not active yet. Everything stays functioning, and you can release this. Because the if statement evaluates if it's the state of that router, because it's also called a feature router, if that is actually active, and it's never active at this moment, so it's always turned off. So even if there's still things to be built inside of the feature, it doesn't really matter because it's never exercised. And then comes that moment, hopefully within a single sprint, where the new feature is ready and it's all good to go. Then you would say, okay, the flag logic starts to evaluate again, and now somehow you can configure that in this configuration that says, okay, now we are on. Maybe under certain conditions, but usually you just flip it on all the way. And that's when the original feature is no longer active anymore, and you start routing everything to the new feature. And this you can exercise. And if you want to revert, because all of a sudden you see that a lot of errors start occurring, you would just roll back and activate the old feature again by flipping the data that is used inside of the flag that is from on to off again. So in the end, you would just remove everything, because that's an important part of this, this work. Then you get rid of everything, and we'll talk about technical debt, because you need to clean up stuff, otherwise there will be more and more and more if statements all around, and all these switches and things will be very messy. So you need to remove all that stuff, which essentially means that the flag, the decision point, is deployed or released 3 times. Once it's deployed, and then it's activated, and later on it's removed again. Now, if you start thinking about this and you think, okay, so what's the big deal with the if statement? Because that's pretty trivial, one of the first things you learn in computer science. But as soon as you start thinking, okay, what can we do with all these feature flags? Then this is actually by Martin Fowler, and the resources are at the end of the slides, which will be available. But he distinguished 4 categories. So one of them that we've been talking about for now is the release. So we can deploy incomplete code, we can time our releases, because it might be a business decision to say, okay, the new search functionality must be available when the campaign, the marketing campaign starts, so it's already there for months, but we flip the switch whenever we think it's a good time to do so. Could be a new brand page that is inside of your website. There's so many possibilities. Usually they're short-lived, because as soon as they become active and it's good, then you can remove them again. So mostly it's always on, always off, and it might be a percentage to slowly rev up and see if nothing goes wrong if you do more and more on. From an operations perspective, you could have a look at the performance statistics. You could use them as manual circuit breakers, because if something goes bad, you can flip it back and just make sure that it's not the new feature that is causing all the trouble. So that gives you a kill switch from operations perspective. And from the experiment side, if you want to do A/B testing, for example, do experiments on how people like a certain new feature, well, then you can do your testing scenarios there. Those are mostly also short-lived, because as soon as the experiment ends, you can remove the toggle again, the flag. And typically you would do a percentage and a time window. So during a certain period, maybe during the day, you will do certain features. The percentage might be some people get 50% gets the new feature, 50% the old, and then you can see what happens between them. And finally, permission-based is looking at the user and targeting specific users. So you can look at things like the claims if they're authenticated. Maybe they need to have a certain flag so they get this special permission level. It might be a certain type of customer, premium customer. It could also be that somebody opts in for new functionality. So they get a cookie, and you expect a cookie, and the cookie determines if you get the new beta features. And you can already try new stuff. This is actually what a lot of companies do to make sure that the functionality is tested by a smaller audience ahead of time. Now, the way this works is you have your application logic. It has this flag router, so the thing that makes the decision in the if statement, and that connects to a feature service. It's not a real service, it's something that takes care of evaluating the feature. And most of the time, it uses a set of rules and settings. The rules are, well, what type of rule do we use for evaluating? Could be the percentage one or the time window. And the settings would be the actual data that is evaluated. So from the day before Christmas to 2 days after Christmas. On top of that, you will typically have a management UI. Could be a separate website, could be a command line, but some interface so you can actually toggle the switches and maybe even see the state of all the toggles. And looking at the settings and the rules, you come up with this thing called, okay, they're mostly key value pairs. A certain key specifying the name of a flag, and then the value. And the value could be something like true or false, on or off, but it could also be this more parameterized sets of data, like day before to day after Christmas. And the other thing to note is that once you start releasing this, and we'll also talk about this in a bit, is that you should be able to change the configuration per environment, because across all of your environments, maybe your testing environment needs different flags than your acceptance or production. Or if you want to do more testing in production style, then maybe you have only production, but separate places where you can gradually scale out. In general, the ingredients for doing feature management is that you would need this in-process service. It's inside the application. It needs to connect to the outside world for storage. That's the most ideal thing. But inside it will evaluate, and it should get the new data, the new configuration whenever it's running, so you can have dynamic updates. That's the most ideal part. But you could choose to have, for example, the release toggles deployed as static data. So it's always off in the beginning, so nobody can accidentally flip the switch on something that is not finished yet. If you externalize it, then the refreshing and the caching becomes a thing all of a sudden, and the ability to vary per environment. And you would need a management plane, like the UI, to interact with it. Now, if you want to start offering this to your teams, or you go back to your team and you say, okay, we've got this cool thing, we need to start working on this. Developer satisfaction, not sure if you heard about it, but it's mostly we can build this ourselves and we can do it better. Mostly I would suggest pick one of the existing things. So on the right-hand side, you have the application frameworks. These are mostly Microsoft-based, so for the Microsoft .NET and .NET Core platform, but there are similar ones for each of all the other ones. I'm a little bit biased as someone that always works with customers that do Microsoft technology, but there's for all platforms, there is something like this. And on the external storage and the management plane, you have software as a service offerings. I've named 3 that are fairly popular. You can use whatever you want, and Microsoft itself is offering a platform as a service thing, so not really the software, it's inside of Azure, and it's called app configuration, and I will use that in a demo in a bit. So for .NET Core, there were only 4 or 5 developers, but who of you is working with .NET Core? Okay, you're the lucky one, because, oh, and a little bit there. I'll keep this brief because there's only 2 people that actually do .NET Core, but I'll show you some glimpses of code and what it means to actually start working with the feature flags. So the application logic needs to find this manager service. This is .NET Core specific. It will register it, it will be injected, so there's all these patterns. So your application logic will be loosely coupled and replaceable with the feature manager that is in use. And in this case, the feature manager will read the .NET Core configuration. And it can do that from static files that are included in the deployment. But ideally, you would go outside and not use the configuration inside of your deployment, because then you would need to redeploy to change the state of the flags. While you read from the configuration, you might come to encounter that if you read it during a web request on multiple places, then sometimes if you have like a percentage, a chance to have a feature on or off, you don't want to have that change while you are in the middle of a request. So you can take snapshots, which is all the state of the flags will be the same during an evaluation of a web request. Every configuration source is available, meaning that whatever is there in .NET Core you can use to feed the configuration system for the features. The feature flags in .NET Core, they can be, the service, the feature manager will be registered with just a simple statement. And then you can choose to have a JSON file, it's the configuration JSON, just lists out all of these things. So this is the context that we talked about, the feature context. It has a couple of features, 1 and 2, that are always off, always on. You can explicitly say that it's enabled for always on, so it can't even be changed. And feature 4 is the one that specifies a certain filter, the Microsoft .percentage implementation, and it says 50% should go one way, 50% the other way. Those feature filters are quite neat because it's an extensible pattern. There's one thing that you need to program yourself, and that's the evaluate. That's where you say, okay, given these parameters, what should I decide? And that way you get the percentage and the time window, but you can do other things as well, like the claims, inspecting the user details, cookies, maybe even the browser type that is being used. This is where you can build stuff yourself, and that's totally okay. Inside of the application stack, and this will be for other stacks, they will be, I think, fairly similar, you want to have some deeper integration, because having if statements everywhere is one thing, but inside of an HTML file, it would not be very neat to have if statements there, maybe not even possible. So integrating in a native form in the thing that you're building at that point could be action filters for your web APIs. Those are the things that react to the get and post, put and delete methods. You could have tag helpers to make it easy to do the HTML side. And the middleware is about routing requests. So you could have endpoints, URLs in your web application that appear or disappear based on the flag being enabled or not. It comes with a NuGet package, so all you do is just do packet management and get the package in, and that should be it. Yes, so this is Azure App Configuration. It's the Microsoft PaaS offering, so Platform as a Service offering. It offers everything that is .NET Core, from the original .NET to Azure Functions, the serverless programming style, and it has Java Spring. So going to Azure App Configuration doesn't tie you to Microsoft technology per se. You can still use it as a backend for configuration if you're doing Java Spring. And as you can see, there's feature management is ticked as well, so you can use that. And this is what it will look like from the UI perspective. Inside of your browser, you will see the list of the features that are there. They might be labeled per environment, and you can just flip the switch if it goes from off on, and it will be custom if you have certain parameters. So I will show you that briefly. Just going through some things. So this application, let me show you what it looks like first and if it's still running. So this is a website that shows the High Score Hall of Fame, and it at the moment has a single high score for Pac-Man, elite score. Not even sure if you can get the 1337, but this is what it does. The front end connects to a web API and gets the high scores from there. So the web API is here. Let's see if it works. So we have the JSON data that's being rendered server-side into this thing here. Let's see, that should be there. There we go. Okay. On the web API side, during the startup, let me find it here. You do add feature management, and the add feature management registers the feature manager, and you can also add additional filters if you want to use them. So this is how you make the special filters known to the system. And that's enough to get everything in place. And it starts reading from the configuration file. But that's just one side of it, because we want to connect it to the Azure App Configuration as well. And that's a thing where we use, so we use the key vault to store all the secrets in a secure way. And from that key vault, the connection string is read to the Azure resource. And then we add this thing here, the add Azure App Configuration, and you can say how you want to connect, how you want to filter, and that you want to use the feature flags. And this, again, is enough to wire everything to the Azure App Configuration, because if we go there, this is what that will look like. So we have an Azure resource that knows about configuration. It's Azure App Configuration, so it can be application settings as well. But it also has a feature manager, and the feature manager allows you to specify each of those flags with certain labels, and it's convenient and often used to have environment names in the place of the label, so you can start doing your filtering there. It's as easy as flipping the switches like this. And the next thing you do is you would start using the feature flag, or maybe not use the feature flag. So let's have a look inside of one of the API controllers. This is what that could look like. So I have a get method in the web API that should retrieve all the high scores as you just saw them. But I'm building this new feature, so I have an if statement, and the if statement says, okay, if the feature is enabled for limiting the list, then you should indicate or execute this piece of code as well. So this is completely new functionality. There's no else. And then we just return the list of all the scores, and that should do it. The thing is that inside of this, and I hope to show that in a later demo, the truncation method actually has a bug in it. So as soon as this feature is activated, it will actually break stuff more than it starts working. But we'll give that a spin in a second. The deep integration that I mentioned, I'll show you one thing, is inside the index page, I'm using this special tag feature, which is ASP.NET Core specific. It's not an HTML thing, but it says if the feature retro fonts is enabled, then you should place this class enjoy. If it's not enabled, then you should do the div without the thing. So this is not about actual execution, it's more about rendering markup in the browser. And if we go here and we flip the switch for development, because I'm on my local machine at the moment. Now let's give this a spin, and it sometimes takes a while for it to pick it up. I see, I've refreshed it, and now all of a sudden we get this retro font, and it looks much, much better. So that's how you can introduce it. And going back to this, if it doesn't work out, or this can be A/B testing as well, then some people you could give this one, and this might take a little longer for it to switch off again. But after a while, it will pick up the new configuration, and it will go back to the original one. That will happen in a bit. See, there we go. Okay, let's try to do the other one, because we saw that there was a limit on the list. So we'll flip on the, I believe we need to flip on this one. Yes. That. And let's see if we can make things happen. But first I'll show you a bit about telemetry. Because now that we can switch things on, oh, well, wait, I'll do the demo anyway. If I go to the web API now, this should still work. Yeah, that works. But if I go here and I do this limit of 0, then actually the scores start disappearing. And it's because I have all these circuit breakers in place. Let's get rid of that. Circuit breakers that they retry a couple of times, but the bug is actually almost endless loop. So it will return, but it will take like 30 seconds for the truncate in the new functionality that we turned on. It will just take too long, and the front end calling the back end will time out after a second. And that's why it says, okay, I can't reach the API, show nothing. But if we do this a couple of times, you see that the time to reload the page is small, but it's approximately a second, a long second, because it's 3 retries and it doesn't really give anything. So I've done this a couple of times. And it seems that it's working, there are no errors, but the things are going bad anyway. What could be going wrong? And that's where the next thing comes in. You need to know if your system is still stable. You need to know what is happening under the covers. And that's talking about the metrics for performance, for stability, and about health information, which is the information that your own application is emitting, indicating I'm healthy or not, and that's the stuff that you should be listening to. Because as soon as you flip the switch, the absence of errors doesn't mean a thing. That's usually what they look for. But if you do all this error catching, then you might actually see that before and after, that before you've flipped the switch, the CPU total was pretty okay, But then afterwards, it starts spiking at these weird moments, and it's like, ooh, this doesn't look good. So this is what you need to be mindful of. If you start releasing, then what you would do is you would specify a couple of gates, quality gates, that look at the telemetry and say, okay, we will check a certain number of things, and we will evaluate at certain sampling intervals. And we want all of them to pass, because if they do not pass, then apparently we're not healthy anymore and we're not good. So in this case, all 3 gates show a green light, and you can say, okay, this is approved, and you might move to the next environment and start doing the same thing there. So this is how you can gradually roll out. Maybe that after a while, after a timeout, you say, okay, never was there a moment that all 3 of them were passing for a couple of times. So we reject the deployment, this is not good enough, and we revert everything. Meaning we flip the toggles with the flags back again. So that's typically the cycle that you start running through, is deploying your new code with the flags in place. And after that's done, you start releasing it and you start watching whatever happens. Now let's see, because we were looking here, and I'll do a couple of more of those refreshes. And we'll go to the live metrics. And I'll make this a little bit smaller so more fits. So as you can see, there's telemetry coming in, but I hope that I can show you that there should be errors coming. There's a lot of errors here. And after a while, it will start showing the dependency calls, so the calls to the API not working anymore. And there you could actually create gates that look at those the data and monitors using alerts and seeing, oh wait, the number of errors has actually increased. Okay. So we have been doing DevOps. We can now at will release something even though it's already deployed. But then you start thinking about, how do we do this for our big cluster or our big solution that we want to release? Do we do it all at once? Because if we flip the switch, maybe hundreds of servers will start acting differently. And then you notice, whoa, it didn't behave very well. So the site goes down and you need to flip it back. That's where you start thinking about what they call the blast radius. So you start small with a small radius of impact. That can be a physical thing. So from different environments. You start with a small environment, then a slightly bigger environment, and then the live production environment. And for each environment, you try to do the thing, flipping the switches. And if the small environment says it's good, then maybe you have enough confidence to go a bit bigger. And that way you do it in small steps until you reach the entire environment. But even there, you can choose to gradually increase the percentage of people that will get the new feature instead of flipping it all on at once, and then everything might go down first time you try that. Another way to do that is from the user perspective. So you define cohorts, groups of people that are identifiable. So they could be, like we said, the claims or maybe an opt-in cookie that they have. But it could also be as simple as you take like a modulo division of their user ID, and every 11th one you would actually give the new feature, and then you do a modulo 10, modulo 9, and so you can gradually increase everyone that's getting the new feature. A deployment pipeline, this is from Azure DevOps. This is a continuous integration pipeline that is not shown, but it produces artifacts. So the continuous integration, every time something is checked in on the branch you're monitoring, it will build the binaries, and they're available as a deployable artifact. That's the thing at the left. And this release pipeline defines 3 environments. And I've used the same ones over and over again. So it's a canary release, we'll talk about that, then early adopters, and finally general availability, and that's everyone. So these are 3 physical environments, and this is where we deploy all of our stuff. So this is the continuous deployment going on, not releasing yet. The blast radius means, and it doesn't really show on the pictures here, it's, but there's like circles of things going bigger. Now it's slightly visible. Okay. Once you've done that, then you can monitor, you can have the gates there as well, because if you deploy the new binary, and all of a sudden your system, without the flags being turned on, already does other stuff, then maybe you made a mistake in implementing the new functionality. So nothing should change for the deployment. But if you go for releasing the feature flags, you do the similar pipeline, fully automated, an important thing, no manual interaction, that's lesson learned, and you flip the switches on each of those environments. Automated, gradually exposing, so it could be in the final stage that you do a percentage as well to slowly increase. Now you might have seen this done with load balancers from the outside, routing traffic, maybe for blue-green testing or blue-green releases. That is what you can do. So you can use and combine all of the techniques that we've talked about before. And what you'll get is that at the end of each release, flipping the flag, the flag to the on state, you have these gates defined. And the gates, once they pop up, they will actually start doing an evaluation, for example, of the data coming in from your monitoring system. And they will say, okay, if in an hour time window, the number of errors has increased by so many %, that's not a good sign, then we disapprove going to the next stage, to the next environment. You can do, this is in Azure DevOps again, it has multiple things that you can do, so that's where you do approval and the checks for your gates to know when it's safe to move to the next stage. But it's all dependent on the telemetry and instrumentation. I'll show you this briefly. So we have here the release pipelines. The build pipeline is a typical thing that just builds the binaries, and it gives a set of deployment artifacts. In this case, it's a couple of images that are pushed to a registry, so it's container-based, and these are the files that are used for deployment. And during release, all that is being done is it goes through the different environments, and if you pick one of those, all it does is a deployment to Kubernetes, releasing the new stuff in there. You would have a similar pipeline for flipping the switches for the flags. And this goes through all of your things here, and if you go to the gates, this is where you can actually define gates and choose what type of gates you want to have. So you can say Azure Monitor Alert, and then you can drill into your subscription, pick a resource group, and it should pick up on the instrumentation. And now this is where you get to choose all of the severities for which time range past 24 hours. So you can just choose how long you want to monitor before you think it's safe to continue to the next stage. All right. From a development perspective, you do unit testing. So you have a piece of code, and all of a sudden it has a flag inside, and it starts executing one way or the other, and doing more of those if statements inside of a single block of code means that your unit test will become a permutation, so a faculty number of the number of switches that you have. Because if you have two, you can switch it either way, and this just grows out of proportion. So think about new strategies to do your unit testing. You should still do it, but you should externalize the things inside of your if statements so you can test them individually and rely on the rest of the things to be to take care of the flags. You would pick your production flag states because that's a representative thing. If you want to have unit tests, then make it as if you're running in production, because you know this one will be on, that will be on as well. And you can also do the same for member of the cohorts, because then you'll know, okay, you will have this one enabled, but that one not as much. And then you reduce the number of tests that you need to run. But going into testing, there's even more. You can do A/B testing. Because you have the ability to switch from one to the other, it's fairly easy to see what the people like best. And this usually goes with the cohorts. A special cohort for early adopters might be willing to see new or old implementation. Could be opt-in, but it could also be out of their control, where you're just offering one or the other. For one customer, you give them the new site. For other customers, you don't do it yet. If you do tenant-based hosting, for example. You can do dark launching as well. Dark launching means that you, behind the scene, you already exercise the new functionality, but it doesn't actually show anything, but you start monitoring the CPU again, because you do let the other things execute behind the scenes as if it were real. And the canary releases, I assume you're familiar with that, but that's the idea that the first time you try to do something new, you try it very carefully, and you want to have an early signal that things are going bad. Just like the canary they took into the mines, if there was poisonous gas, the canary would die, they would just fall down, and you would know, okay, we need to get out of here. That's so small environments where you do the canary releases. But the testing in production is actually pretty strong, and with this you can do that. Because you can fake as much as you like, but only in production will you have real data, the actual number of users, and that's where it really counts. So that's where you do your quality assurance and your user acceptance testing inside of the production environment. And this is fairly safe because you can flip it on and off again. A/B testing, well, I think I've mentioned most of this. If you have an hypothesis, so something that you think, okay, menu on the right-hand side or the left-hand side, what will be better? You can start doing that. Do it by means of offering 50-50 or maybe a small and a bigger percentage. But always measure, get the feedback, get the smiles or the frownies, and do your A/B testing with your audience in production. And it means that you can use that filter inside of your code instead of having to deploy two separate versions, put load balancers in front, do dynamic routing, and it's all at the network level, which also works. But in this case, you don't actually need any of that. So it's very low threshold things of getting started with A/B testing. Then we've talked about this, so the life cycle of a flag itself, the state is, usually it's always off to begin with. It's never on until it's completed. Then you go into this mode where you start toggling it on and off depending on certain things or if stability. And finally, you put it on always on. And at the end, when it's always on, it doesn't make sense anymore to have the flag anymore, so you should remove it afterwards. Now, the final part of this session, we can talk about if you start doing this and the development teams go all out and everybody's happy because we can flip switches and the number of switches, the flags grows, that might actually be a bad sign. Because if it starts growing, probably it means that it's not cleaned up. So that's a smell. You should be wary of that. The other thing is, if you see that a single flag is being used in multiple places, you flip a switch and all of a sudden all of these things light up across your distributed system. That also might be a smell, because how can you make sure that if you flip it, that three things start turning on, maybe one of them goes bad, but how would you know which one it is? So you could look into things like strategy pattern, for example, maybe duplicate code instead of using if statements. The other thing is fine-grained toggles. If there's like really small bits of code that start doing the if statements, that might be too granular. And also, think about it from a DevOps perspective and an Agile perspective. It's all about business value. If you see that you start toggling technical capabilities more than it is actual business value, is it really a feature? Or is it just internals more on the operations side? Could be good, but it's a smell, so you should investigate. This is about the pitfalls, the things that can go bad. You can get into a lot of trouble if you start combining feature flags, feature toggles, because then it becomes unclear if you flip a switch if something really starts happening. And that can be really, really complex. And nobody knows what is doing what anymore, especially the second to last one. If you don't describe what a toggle does, it says something like improve performance and flip the switch. And then you think, okay, what does it do? Nobody knows, but we flip it because it should improve performance. Not really good. If there's the long-lived one, you might actually be hiding other functionality than is what is supposed to be behind the feature flag. Maybe it's just configuration for certain things. If you launch in the blind, that's also not a very good thing. That means that you don't have any clue what is happening as soon as you flip the switch and you have no instrumentation or telemetry. Another thing is, this might trip you up. If you don't get your configuration and your management plane out of your application, just imagine if you flip a switch, because the UI is also hosted in your application. It has this admin page, and you go to the admin page, you flip the switch, and all of a sudden, your site goes down. You go, whoa, okay, let's flip the switch back. But your admin page is no longer reachable because it's inside of your application that has just died. So that's something you also shouldn't do. And the final one, repurposing feature flags, means that you have a feature flag, let's say improved search algorithm, and you use it for one feature, and then you start using it for a new feature that is also about search algorithms, but it's very useful because it's already defined and we can reuse it. If you want to read well, it's not a funny story, but it's a valuable lesson, and it actually costs a lot of money. Go read about Knights Capital, which is an investment brokering company. What they did is they had this moment where they had 8 servers. They did manual deployments to all of the machines, but the 8th one failed. And they did it manually. They had no checks to see if it was successful. So one of the machines had old code, testing code, with a switch. But they used the switch for the new code that was on the other 7 machines. So when they turned it on, 7 machines started behaving in the right way, but one machine did it wrong because it was using the old code, the new one wasn't there, and the switch, the flag that they reused actually turned on this testing code, doing not so smart stock deals. And they started losing money because they saw, whoa, we are losing money fast. I believe a couple of million per second. So they thought, okay, we need to revert this. So what they did is they redid the deployment of the old code to all the other 7 machines, essentially making it worse because now they were all doing the wrong thing, and they lost in 45 minutes $440 million. It's a well-known case. They went bankrupt immediately because they reused a feature flag. Don't do that. Well, if you negate all the pitfalls and the smells, then you come up with, okay, don't do long-lived functionality under a feature flag. That's not a good idea. You should separate it, like we said. Don't have your management inside of your application. And the other thing is keep track of all the flags and how they're being used. Because once you have this feature flag, initially it will not be evaluated because it's always off. Then you start using it and you can see, okay, it's being actively used. And after a while, it will be always on. And that's also an indication that if it's already on for a month or so, it's usually a good reminder that you should be removing it. So looking at how it's being used also gives you an eye on your technical debt. Enable just one of them at a time, because if you do one, you can monitor. If you flip multiple switches, it's like a physical experiment. a physics experiment. If you do multiple things at the same time, you can never really understand where it came from. Other things to keep in mind, it might be that your external system that keeps track of all the configuration is not there yet. What do we do if we can't read the configuration? And what should the flag do? And then you should fall back to, well, and talk to your product owners, the ones that decide, what should we offer? Should we do it or do the old stuff? That's another thing you can do. And to avoid all the granular, the small feature toggles, start with big ones first. And if it turns out that you can't, it's too coarse, so too much at the same time, you can introduce additional flags. You can be more granular and flip on smaller things. Another thing, naming convention for your flags. Think about prefixing them with temp, for example, to indicate it's a temporary flag. Maybe the longer-lived ones or ops ones will get other things. But that's a mean of indicating where a flag can be used. For example, adding UI at the end means that it can only be activated from a UI application because maybe it needs HTTP information and it's not available in a background service. That's it from my side. We've looked at feature flags as a means to decouple your deployment from releases. We've looked at all the scenarios to do continuous release throughout your application with deployment first, release through flags, increasing the blast radius, doing all this testing scenarios with A/B testing, for example, and having a safe way to get from old functionality to new features in a DevOps style where the team is in control and doing a modern style of development. So I believe we have time for questions.
Absolutely. Thank you. Thank you very much, Alex. And yes, we have like 7 minutes for questions, and take your seat.
Oh, we sit down, okay.
And actually quite a few, so probably we would not ask all of them, but I will remind that there will be a discussion zone after the talk. And let me ask this first question. Using the feature flags enables for much faster enabling of the features, including sometimes those not fully ready. And what about possible side effects? Or what about the data you can actually change while enabling the new features? It will be easy to switch the feature back, but you will have the traces in your data. And as we heard previously, data in our cloud applications is what actually has of much higher value than everything else. So how does and this is not the feature flag thing. This is more like a thing for all of the continuous deployment things. But does using the feature flags helps to do anything about it, or it maybe doesn't? And what is your personal experience about it?
Okay. Starting with the first part, if you have features that are incomplete and you accidentally turn them on, that's what you started with, and changing the data.
Yeah, so, one of the cases, yes.
Yes, so that's where you would probably lock it down as marking it with always off. So it's not switchable, that's an indication. Because if, depending on the tool you're using, if you have the freedom to switch, you could do so. But if you mark it as always off, it's a special filter that never ever can be turned on because it's disabled after that. So it will need a new deployment, for example, or a change of the parameter to actually make it able to be turned on. A safeguard, just to make sure that we don't turn it on if it's not ready yet. But once it is, what you mentioned is a difficult thing if you do a lot of releases with the database. It is tricky. So I think you should have 2 implementations that hold the same business value, do the same behavior. But if the underlying database schemes, that's usually what it's about, the database structures changes and it starts writing into additional columns and extra data.
So should we await in the near future feature tagging the data?
I think that if you do changes with that are under a flag that have two types of functionality, one uses the old database, the second one uses a change database because there's more customer data being stored, then you should have a scenario and a strategy for moving your database forward. And you would do approximately the same thing. That's what we do. We first change the code to just the code reading to and from the database to be compatible with the original database schema and the new database schema. But the new database schema isn't there yet. But you can already have that in place. And then you change the database schema in a transaction, creating new tables with the new structure. And then you can also flip the feature flag and the data should be copied over, but you can start working on the new data. And if it doesn't turn out to be functioning properly, you flip it back and you could even decide to go back to the old data, old table. Creating a new table is a way of not locking your databases during the upgrade, so you have zero downtime. But it's advanced. But I mean, if you flip the switch and you start doing stuff, changing the data and turning out that it's they got wrong prices is really a tricky thing.
Yeah, I think that's still one of the trickiest things in employing all this, very quick update stuff. But okay, let's go for the next question. So what do you think, how it compares the approach with feature flags, which are hard-coded, for example, in the code, with just controlling the traffic between a few versions of products, which is probably what we call blue-green deployment or something.
Yes.
And sometimes you can do this on a lower level for canary, but what are pros and cons of using one or another? Should we forget about controlling traffic and just go with feature flags instead, or they have the benefits and weaknesses?
Being an architect, I like to say it depends. I think they're both valuable and have their merits. If you have the ability to do controlling of your traffic at a higher level, that's totally fine, but it would mean that you need to deploy completely separate versions, duplicate your resources, so it will be an increase of your resources. And if you have a monolithic application, you start running two things, and you can only flip one between one and the other. But there might be 10 or 20 of things you want to flip on and off, and how would you do that if you can only route traffic to two things? So the way to the speed to accelerate might be slower instead of deploying a new version and then just flipping switches whenever you see that the telemetry says it's still good.
Now I like the idea really, because you can still keep your monolithic application and say that we are using the very, very modern way of deploying, continuous deployment. This is nice.
Yes.
Okay, we probably done now, so I would suggest to continue the discussion in the discussion zone. Thank you very much, Alex, once again. And thanks everyone for coming here.